pathogen. When it binds to the helper T cell using that MHC2 complex, I release those cytokines. Those cytokines tell me to start making lots and lots of plasma cells that make tons of antibodies, and to also make a few memory cells so that next time I see this, I can fight it. Okay, so once those antibodies are made and they're out and about circulating in your cells or in your body, these are doing the humoral response. Remember, humoral is our bodily fluids here. Okay, so these antibodies are out in our humor, okay, or our bodily fluids, doing this response. And so these are some of the things that antibodies can do. They can neutralize the foreign invader. Okay, they can coat the epitope so it can't bind with other receptors. Remember, the epitope is where things bind to the antigen. So they can coat the antigen. Basically, they can coat the antigen so it can't interact with your cells. Okay, they can cause these agglutination reactions, like with like we talked about before your freshman year with blood typing and blood transfusions. You can get that clumping. So you clump all those antigens together, and now it makes it easier for the macrophage to come eat them. Okay, so we clump them up together and the macrophage can eat them. We neutralize them, again, making it easier for the macrophage to eat them. We can also trigger what's called precipitation. Okay, and so if the antibody binds to a soluble antigen, then that antigen then will precipitate out and again can go through phagocytosis easier. Okay, antibodies can also trigger the complement system. Remember the complement system forming that MAC complex and going and poking holes in all of those foreign cells. So it can trigger the complement system, working with the innate immune system there to kill the cells. It can also help with the opsonization. Remember when it marks those cells for eating by the phagocytes? Okay, so those are all ways that antibodies can go help take care of antigens. We've been talking about these memory cells that can be made. Okay, so we've talked about how memory T cells can be made and memory B cells can be made. So let's look at the importance of these. So what these cells do is they help us remember. They help our body able to fight a disease. So like for instance here, if I look here, this is my primary immune response here. Okay, this is my first exposure to the antigen. You'll see it takes me almost 2 weeks to get up to peak antibody formation. Okay, upon my second exposure, you'll notice my antibodies never dropped back down to 0 because I had some of those memory cells there. So now at day 28, I have a second exposure to that disease, to that pathogen. But now because I have memory cells that remember it, they get activated, and you'll notice I have a significant higher response to the immune system, with antibody production. I'm making triple the antibodies, and I've also done that in a week, in 7 days, as opposed to 14 days. So my secondary response is significantly faster because of those memory cells. So let's take a look then at immunity, because immunity is one of the things that people start to talk about with this, because immunity is going to be when I don't have a response I don't have the disease at all. Okay, my secondary response is so fast, it's so in tune, I'm not even getting symptoms of this disease. So I have a couple different kinds of immunity. Okay, and again, remember immunity here, that exposures to the disease are not actually getting me the disease. Okay, so I have two basic kinds of immunity, active and passive. Okay, and I have two basic kinds of each one of those. So active immunity, okay, I've had exposure to the pathogen and I've made memory cells. I've made my own memory cells here. Okay, well, I haven't necessarily made my own memory cells. Well, I have, but let's talk about the different ways as why I've made my own memory cells. So active immunity, I've had some kind of exposure to the pathogen, and that's given me immunity because I've made memory cells. Okay, and so I've got what's called natural active. Okay, and so natural active immunity is typical immunity. I got the disease, I made memory cells, I am naturally immune to it now because I had the disease and I made some memory cells. Artificial active immunity, that's your vaccine. So I've been exposed to the pathogen. I've been given an inactive pathogen, pieces of the pathogen. I've been exposed to inactive pathogens, which is strong enough to make me make memory cells. So I didn't actually have to get the disease. I just had to be exposed to the pathogen, and I've made the memory cells, and so that's given me immunity. So it's artificial immunity because I didn't actually get the disease. Okay? In passive immunity, the memory cells are given to me. So I did not make my own memory cells here. They were given to me. So that can be due to natural passive immunity, and that is involved with mothers and infants with breast milk. So the mother passes on the antibodies she has in the breast milk, and while she's pregnant and the fetus is developing, she passes on her antibodies to that developing child. So the child doesn't make any memory cells because it's just being given antibodies. Okay, the second one is our artificial passive immunity. So artificial passive immunity, again, you're going to be given antibodies, but you're going to be given antibodies with a shot. This would be something where the disease works so quickly and so rapidly that if you gave your body a chance to make its own antibodies, you wouldn't survive. This would be something like rabies. Someone is bitten by an infected animal. They haven't had a rabies vaccine. Okay, they will receive artificial passive immunity to rabies. They will be given rabies antibodies right away. 2 things left, and we're going to go through them hopefully super fast. Okay, just hang in there with me, guys. Okay, so we've got the innate immune system going crazy. Okay, so if the innate immune system goes crazy, usually that's going to be overwhelming inflammation. Okay, lots and lots of inflammation. Think like I got stung by a swarm of wasps, so I've got inflammation happening all over the place. So I've got tons and tons of histamine being released. Unfortunately, way too much histamine. Okay, so histamine remember, it makes the capillaries more permeable, makes them leaky. So I've got all this fluid going into the tissues. Okay, and what it can do is it can drop my blood pressure dangerously low because I don't have enough fluid inside my tissues. So the innate immune system, if that gets out of control, okay, that can be fatal. The blood pressure can drop so low that it can be fatal. Okay, so let's look at an adaptive immune system going crazy. We're not going to spend a lot of time on this because our adaptive immune system stuff that can kind of go quote-unquote crazy, okay, that is going to be stuff we're going to talk about later. HIV, we'll talk about genetics again, okay, but adaptive immune system going crazy, these would be things like our autoimmune disorders. These cells aren't doing their job in being able to recognize what's yours and what's not. Okay, an example here would be Graves' disease. Okay, type 1 diabetes would be autoimmune disorders, rheumatoid arthritis, multiple sclerosis. Again, things where your body is attacking itself. Okay, blood transfusions would be an example of the adaptive immune system going crazy. Okay, remember, with our blood transfusions, we need to mix like with like, right? If somebody has type A blood and we give them type B, well, they had type A blood, giving them type B, now I'm going to start, my type A blood is going to start attacking that type B blood. Okay, and so when my type A blood that has antibodies for type B starts attacking that, I get those agglutination reactions. So that would be the adaptive immune system struggling there. We also have what's called the Rh factor in women. Okay, so you talk about somebody being A positive or B positive or O negative with their blood. Okay, so Rh factors are that positive negativeness, and that becomes an issue for moms with their second child. If the mom is Rh negative and the first child is Rh positive, okay, during birth, some of the blood will get mixed, and so mom will get exposed to these positive Rh factors here. And so she'll make antibodies for those. So now that she's making antibodies for those, if her second child is positive, she's making antibodies, so she's attacking that kid. Okay, and so they work that out by giving the mom a shot. If a mom is Rh negative and the first kid is Rh positive, immediately after birth, the mom will get a shot to suppress the formation of those antibodies, so that the second pregnancy and the third and the fourth and the fifth, okay, all of those are going to seem like the first pregnancy for her immune system. when we're talking about the immune system, we've got to talk about HIV. And we are not going, we're going to talk a lot about HIV with viruses and how it works. Okay, so what we need to focus on right now is really just what HIV does to your immune system. Okay, so you know, HIV kills these helper T cells. Okay, so when people are infected with the HIV virus, their helper T cell concentration, as the HIV virus increases, their helper T cell concentration is going to decrease significantly. Okay, and so as that helper T cells decrease, then remember you're not able to activate those B cells, so you can't make antibodies. As most of you guys know, most people that are infected with HIV, they die from secondary infections because you're killing these helper T cells. You're breaking down the cell membrane of the helper T cell, so that kills it. The HIV can stimulate apoptosis of the helper T cell, okay, and it can also trigger cytotoxic T cells to attack the helper T cells. So a wide variety of things that HIV